So I was going through my computer the other day, and I found some of the first programs I ever wrote. This was in high school, and we were using this Python framework called Pygame to build like these very simple games. There was a ping pong game, like with the sliders, and there was also I also just screwed around a lot. And I remember I had a ton of fun. That was pretty much the class that sparked my interest in programming because I was doing something fun and creative, all the while like learning the basic for loops and so on. Um, anyway, I thought it would be fun to do another simple Pygame project, and seeing that it is currently snowing in Toronto, let's create an animated screensaver together with snow in the background. Welcome back. I got VS Code open here and we're going to start the project, which shouldn't take too long. First thing I'm going to do is I'm not going to start from a blank file. Instead, there are these simple, really simple boilerplate files, like sample files, which essentially just set up the program for you so you can fill in the functionality. And I'll just copy this. This is how the majority of code is actually written, by the way. And I'll just make a new file here called snow.py. All this should do is just create a Python window. Where'd it go? Okay, here. Okay. Yeah, all this should do is create a Python window here and just animate a simple circle. Okay. So I'll just quickly go over what already exists in this file. Here we're importing Pygame and we're initializing the module. This sets the screen size. Trying to remember like all these years ago, what is it like? And here's the main loop. So essentially, as long as this while loop is running, that window we saw earlier will continue to show on the screen. By the way, I'll include the link to this boilerplate file in the video description. Alright, so my plan is essentially to use this sample file to build up the screensaver like slowly bit by bit. First thing I'm noticing here is ideally you want a black background with white snow. So alright, so we got one snow particle. Like one thing we can easily do is just draw more of these, maybe at random locations. You should be able to see some more snow on the screen. Oh, I forgot. Okay, it's being drawn. Okay, that's the. Okay, that's not exactly what I wanted. The problem is at each iteration of the while loop, new snow is being created at like random locations and there's no like continuity. Snow doesn't like appear and disappear. So we gotta somehow keep track of the positions of the snow particles. And I think like one simple way we could do that is we can create an array just to store a few locations. And while we're at it, we can also like initialize the snow list with random locations. This is a good opportunity for like to create a snow class and do like more of an object-oriented approach, but I don't think there's just going to be snow in this simulation, so I'll just leave it as a list. And here, this is going to be the X location of the yeah, X location of the snow part. Is it X first? Yeah, so XY, yeah, XY. So this is gonna store some value between 0 and 1000 from 0 on the width, and here for the number of snow, let's start with 100. That might be, and here going to all. So this is the color, the location here. Oh, we should iterate over the snow list object. So this is and snow dot, oh no, snow, the first element will be the X coordinate and the second will be Y. Let's call this particle actually. And what's not Y? Yeah. Okay, let's see how this looks. Okay, that's better. It would be nice if also the snow were of different size. So let's quickly also let's add another element here in the snow array, which this represents the snow size. I think we'll go from 0 to Alright, that's not bad. That was starting to look more like snow. The next step, let's try and make the snow fall. One way we can do that is before drawing the snow particles, we can iterate through the snow list and like increment the Y coordinate of each snow particle. And we'll start with a value. How many pixels should we, how fast should the snow fall? Let's start with 5. Let's just see what that looks like here. Okay. I think that's a little fast. Okay, 5 is a little fast. Let's try. Oh, why? It's because, oh, I know why. Okay, there's this thing in Pygame where if you don't want the simulation to run that fast, I think you need to use this method called, like, right? Okay, right here, yeah. So by calling clock.tick, you can delay the frame rate so the simulation does not run that fast. So let's give that a try. Let's try 3. Okay, that's not bad. Alright, but now the snow is falling outside of the screen, so like one way we could try and detect that this happens is for each particle. Yeah, so here we increment make snowfall, and here we can also detect if snow has like fallen past end of screen. So if for each particle in the snow list, if the Y position of the particle is greater than the height, then we can, oh, it's easy. We can just set the we can just set the y position back to like 0 again. So let's see if this works. So it should just recycle back to the bottom of the screen. Okay, there we go. Yeah. Nice. So that's not bad. I'd say we're almost there. Is this how snow falls? Okay, snow does not fall completely straight down, so we should add some kind of irregularity to the snowfall a bit. Maybe like wind or drift. Okay, and we're gonna add one last item to the snow array item, and this is going to be like a drift value. If the drift value is like negative, then the particle should move left, and then if it's positive, it should move right. So this should be between -1 and 1. I guess snow falls straight down sometimes as well, so we'll leave 0 as one of the possible values. Now, add the fourth element. Let's just see how this looks here. So this is what I'm expecting to see is like snow that. Okay, yeah, that's not bad. There we go. I'm just looking outside. Does this look like snow? Okay, I think we can use a few more snow particles, and that's what's there, I think. No, fine. Or like with like with it. Okay, yeah. There we go. Can see that snow is... Oh wait, there's a problem. Okay, so there are two problems. The first problem is the snow is only either falling directly down or moving left, and that's because this rand range it doesn't include the value 1, so we need to make it 1 more higher to include the value of 1. And also the second problem is the snow will eventually drift off the screen, and Pygame will not detect whether you're drawing a particle that's actually beyond the bound of the screen, so it will not... Those particles essentially get lost over time as the simulation runs. So we need to also check so if the x position of the particle is past the width, we want to set the x position back to 0. So if the particle has moved past the right side of the screen, we can reset it to be 0, so it starts again at the left side of the screen. So I'm going to follow a particular particle here. There's too many. So this one, it should appear here. There we go. Okay. All right, I'd say that's not bad. You can find the code for this file and usage instructions linked in the video description. I'm hoping this gives you some ideas for like your own simple projects you can make with Pygame. Pygame is actually like a really powerful library, and people make some pretty impressive like interactive games with it. So I recommend you really check that out.